All right, so this is the study guide for 3.1 to 3.3 functions, linear inequalities. So it says determine whether the relation is a function. Remember, if something is a function, it has no repeating x values. So I'm really focused on the x values in this whole quiz, okay? So here, I'm just going to be looking at the x values. That's going to be this input. And I notice that I have two zeros right here. So because there's two zeros, I'm going to say it's a relation. And why? Well, I'm going to say because the x values, and I could write input, or I could write the independent variable, but I like x values here because it's pretty straightforward. Because the x values repeat. Okay. Now, with a set of points here, I'm just going to be looking at this first one because it's alphabetical. X comes before Y. So I notice I have 5, 4, 1, 3. Well, this is going to be a function, and the line got moved, so I'm just going to write in this empty space. So Y, well, the x values do not repeat. All right. Now, question number 3 asked me to determine which one is a function and explain why. All right, so first thing I'm going to do is whenever you have a graph, you're going to want to have a vertical line handy, okay? And basically, I'm just going to drag this vertical line across my graphs here, okay? And that's all I'm going to be doing to determine just, that quick. And if it touches this green vertical line in more than one place, then it's not a function. So let's start down with C, because I want to leave A to talk about. So I noticed that it touches twice right there, up here and right here. So C is not a function. Likewise, D is not a function. Now you might be wondering why A and B are on here, because it's pretty much the same exact diagram. Well, here's why. With A, notice right here, I have two closed circles, right there and right there. Two closed circles means that both those points are included. So therefore, my graph touches my vertical line twice right there. Now, why is B acceptable? Because there's an open circle. This circle is open, and this one is closed on the bottom half. So it actually doesn't touch in two places. And that is why, okay? Because it passes the vertical line test. Now, number 4 says the set of ordered pairs below is a relation that is a function. Which ordered pair could be included so that the set remains a function? Well, again, here, really worried about these x values because I know these x values can't repeat. So I'm going to look here. I have -5, -4, -3, and -2. So which one can be included? All right, because it says could be included. Well, notice A has the -5, which is already being used, so I can't use that. All right, B, -6, and -1 are not being used. So therefore, B is my answer. And just to reiterate it, -2 in C is being repeated, and -3 in D is being repeated, okay? So that's why C and D are not my answers. Now, number 5 says a relation is shown below. What is the domain of the relation? Domain is just talking about what are my x values. So my x values here are 2, 5, and 14. Okay? So if we have 2, 5, and 14, the one that matches up there is A. Okay, A. Now these are a little trickier. What are my domains and ranges? And again, the spacing got messed up, so I'll just put it by the domain and the range. Well, the domain is going to be if I turn on gravity and all these balls fall, okay, don't forget this guy right here, they fall down to the x-axis. What are those values? So they are -2, -1, 0, 1, and 2. Now, what is my range? Well, it's kind of like, well, what if I were to smush them in, like between two elevator doors? All right, and I trace them over to my y-axis. So they are 4, 2, 0, 2, and 4, okay? Because I have them on the other side. All right, you don't technically need to repeat them, but I'm going to do it so you can see that there's the same number of domain and range here. Now, number 7 is a little tricky because it's continuous. 6 is discrete, it's a bunch of dots. 7 is continuous. So I'm going to have a range here. Now, I do the same thing. I drop these endpoints down, okay? And since they're closed, I have the closed inequality symbols. So my domain is going to be 0 because that's where it falls on my x-axis, and 6. These 2 points here. Now my range, well, if I smush it against my y-axis, okay, same thing, same symbols because they're closed points. Well, my lowest y value is 2, and my highest y value is 5. So it's a range of values. Now for 8 and 9, I have domain and range. Well, my domain is going to be, well, notice I have the arrows on, meaning it goes on and on forever and ever in those directions. Now, if he keeps going on and on in this direction, notice my domain could be all real numbers. It could be anything. You could use this symbol if you want. Now my range, well, notice my range is a little different. There's a bottom, right? There's the bottom, and it can't be below that. Notice my graph doesn't go below that. So my range is going to be y needs to be greater than or equal to 0. All right, it can be anything above 0. But notice my graph doesn't have any negative numbers. Having said that, we move over to number 9. Number 9, well, the same thing. Domain can be all real numbers. It can be anything. I got those arrows in on the end. But my range, well, look, here's the bottom of mine, right? And that is -2. So y has to be greater than -2. Now, which value is not in the range of the function? Well, what does that mean? Well, it means this. I'm going to look at my graph and I'm going to see if I can get y. All right, those y values, A, B, C, and D. Okay, so for A, it says 0. So I'm going to put a point at 0. Of course, my board is not aligned, so there we go. Look at that. All right, so there's 0. And now what I'm going to do is I'm going to trace it over to my graph. Notice that's there because there's a solid circle. So which value is not? Well, A worked. Well, let's look at B, 3. So 3 is right here. Wow. Okay. So 3 is right there. Now, if I draw a line over to my graph, notice there's a hole there. It's missing. So this is my answer, but let me show you why C and D are. Look at -4. -4 is right there. If I trace it over, there's a solid circle. I'm also already on my graph. There's a line there, so I'm good. And 5's right here. If I trace that over, notice I get a circle. So that's why B is not part of my range. All right. These ask to identify the independent and dependent part, and then explain why it's discrete or continuous. Okay, I know it says of, but it's going to be discrete or continuous. So identify the independent variable. Well, it says the function C equals 0.60 t plus 5, which represents the amount charged for hamburger C based on the cost of a plain hamburger, plus an additional charge for each topping, T. So the toppings are going to affect the cost of my hamburger. So therefore, independent is going to be toppings, and dependent is going to be cost of the burger. Now, is it discrete or continuous? Well, in this one, it's going to be discrete. And here's why. Because it's going to end up being a bunch of points on a graph, because you either have the topping or you don't. Okay, I can't have half a topping. I can't have 3/4 of a topping. It doesn't work like that. They either put the topping on or they don't put it on. Now with this one, it says the function f of x equals 300 minus 75 represents a flight of a helicopter where f of x is the number of miles the helicopter is from the destination after x hours. Identify the independent and dependent variables. So independent is, well, we're looking for what is x? X is hours, it's time. Okay, x is always your independent variable. And miles away is going to be your dependent. Now, is it discrete or continuous? Well, we're not playing Call of Duty here, so this is actually going to be continuous. Why do I mean we're not playing Call of Duty here? Well, let's think about this. In Call of Duty, you glitch and you skip across the map. You don't move smoothly. But in real life, we don't glitch. We're not living in the matrix, so we're not glitching through. Okay? So you have to smoothly transition. Now find the domain. Well, the domain is going to be, well, if we look at that original problem, it says 300 minus 75x. So this was the equation. Now, this one's a little tricky. I have to figure out, like, how long will it take me to go 300 miles? Now, why is that significant? Because once I get there, I can't go negative miles. So I come up with 4. So my domain is going to be anywhere between 0 hours and 4 hours. And all I did was, I thought to myself, well, how long would it take me to go to 300 miles? Okay, if I'm 300 miles away and I have to get home, how long would that take me if I go 75 miles an hour? That would take me 4 hours. Now my range, well, my range is going to be, okay, well, it's going to be 300. That's the furthest I could be away. To anything less than that, all the way down to 0. I guess I kind of wrote that backwards, so we could say, well, I could be 0 miles away from home, all the way up to 300 miles away from home. Doesn't matter which way we do it, saying the same thing. Now, number 13 says evaluate. So evaluate just means I'm going to replace the x with the -2. Well, there we go. So f of negative 2 equals, keep that negative outside, negative 2 squared is going to be 4. So f of negative 2 equals negative 4. All right. And that's it. Now, I will let you know if you're watching this, there is one extra credit problem. Okay, it's going to look very similar to this helicopter problem. Okay, so study that. And yeah, good luck.